third lecture in module 5, that is the model adequacy checking. Here is the content of this module. We have already talked about various types of residuals, like regular residuals, standardized residual, studentized residual and pressed residuals. And also we have talked about two residual plots, like normal probability plot and plot of residual against the fitted value yi hat. So, what we are going to do today is that we will be talking about plot of residual against the regressor, and we will be talking about partial residual plot, and finally, we will be talking about the press statistics. Okay, so first we will be talking about the plot of residual against regressor. Okay, so here we are in the multiple linear regression model setup, multiple linear regression, and we have the response variable y and several regressor variables, like x1, x2, maybe beta k minus 1, x k minus 1 plus epsilon. So, like residual against yi hat plot, here we will be plotting the residual against the regressor x1 and then again residual against x2, like that. And this particular plot, this plot of residual against regressor is important in determining relationship between the response variable y and regressor xj. Okay. And also this plot are very similar to the plot of I mean the pattern of the plots here in the case of residual against regressor are very similar to the pattern of plot in case of residual versus yi hat. So, in this case also here instead of yi hat we will plot some regressor xj, and here also the residuals containing in a horizontal band is desirable, and this is treated as this sort of horizontal band containing all the residuals indicates a satisfactory model, and the open funnel, I mean like whether it is similarly here also, you know, instead of yi hat we will be plotting in this horizontal axis xj. So, here also the outward open funnel indicates that the variance of I mean indicates non-constant variance, like whether it is outward open funnel or inward open funnel, that indicates non-constant variance. Similarly, in the case of double bow also, for example, xj here and xj here. So, all these things, you know, this double bow also indicate non-constant variance, and this type of nonlinear pattern indicates that the assumed relationship between y, the regressor the response variable y, and xj is not correct. So, that means, you know, we have to consider the extra terms, like, you know, maybe the higher order regressor, like for example, xj square or xjq, or some transformation on xj, for example, maybe 1 by xj or maybe log xj. So, this is what the nonlinear curve indicates. So, what we learned from this residual against the regressor plot, this is important to determine the relationship between the response variable and a particular regressor xj, and the limitation of this plot is that it may not show the marginal effect of xj, a particular regressor xj, on the response variable, because what we are doing is that we are plotting residual against a particular regressor. And let me tell little bit more about this one. So, what we do here is that we are plotting EI against a particular regressor xj. Okay. So, what I told that, you know, the limitation of this plot is that it may not show the marginal effect. You need to understand this part, you know, this plot it may not show the marginal effect of a regressor xj given the other regressor in the model. See, we are talking about multiple linear regression. If it is simple linear regression, say simple linear regression, and there is only one regressor, so y equal to beta naught plus beta 1 xj, beta 1 x. Okay. So, in that case, in case of simple linear regression, there is no difference between the plot of EI and yi hat and the plot of EI against xj. So, those two cases are same, and I mean in case of simple linear regression, the plot of EI against yi hat is same as the plot of EI, the residual, against x, because there is only one regressor and they are linearly related. So, whether you plot against x or y, it does not matter. But in case of multiple linear regression, there is a difference. These two cases are not same, because there are so many regressors, more than 2 regressors are there. So, what I told here is that the limitation of this EI against xj plot is that that may not show the marginal effect of xj given the other regressors in the model. Okay, so that is why we need to go for partial residual plot. So, I will try to explain the partial residual plot now. This is an improvement of residual against regressor plot. So, this is called partial residual plot. Okay. So, what we do here is that here in the partial residual plot, consider the marginal role of the regressor xj given other regressor that are already in the model. Okay. Let me just give the outline of this plot. What does this partial residual plot does, and then I will try to explain the logic behind this plot. So, what it does is that in this plot, the response variable and the regressor, say xj, are both regressed against the other regressor in the model, and the residuals are obtained each regressor. Regression. So, what I told is that this partial residual plot consider the marginal role of what is this marginal role of the regressor xj given the other regressor that are already in the model. So, since we are talking about multiple linear regression here, we need to consider the role of the marginal role of one regressor in the presence of other regressors in the model. So, the technique is that first you both the response variable y and the particular regressor xj both are regressed against the other regressors in the model. So, here the response variable y is regressed on all the regressors except xj, and similarly xj is also regressed on the remaining regressors. Okay. And then the plot of, so we will get two residuals from these two regression fit, and the plot of these residuals then we plot so there are two residuals. One is there is two regression model we are trying to fit. One is we are trying to regress the response variable on all the regressors except xj. So, this is one regression model, and the other one is that xj is regressed on the remaining regressors. So, this is the second regression model. From these two, once you have the fitted model for these two regressions, these two regression model, you will get the corresponding residual values, and then you plot those two residuals to get the this marginal residual plot. Okay. The plot of these two residuals against each others show the marginal role of regressor xj on response variable y in the presence of other regressor in the model. Okay. This partial regression plot is little difficult concept, I'll try my best to explain it. Just now I will give one example which consists of two regressors. That means I'll take an example of multiple linear regression model with two regressors, and I'll try to explain the technique first, and then after that I'll try to give the logic behind, the idea behind the partial residual plot. I said that this partial residual plot consider the marginal role of xj. So, you need to understand what I mean by the marginal role of xj on the response variable in the presence of other regressors in the model. Okay. So, there are several regressors I told. Okay, let me just first give the give an example to illustrate the technique what I explained here, and then I will be talking about the logic behind this partial residual plot. Okay. So, here is the example here. Let me illustrate the technique first. The illustration. So, consider multiple linear regression model with two regressors x1 and x2. So, my model is of this form y equal to beta naught plus beta 1 x1 plus beta 2 x2 plus epsilon. Suppose for example, I am interested to know the marginal role of x1 on the response variable y in the presence of x2. Okay. So, I am interested, suppose we are interested in marginal role of x1 on response variable y in the presence of other regressor in the model. Okay, so, according to the technique, what I will do is that there are two regressors x1 and x2, and I am interested to see the marginal role of x1 on the response variable. Okay. So, first what I will do is that my aim is to eliminate the effect of x2. See, there are two regressors x1 and x2. I am interested to see the marginal role of x1 on y. So, what I will do is that I will just first I will eliminate the effect of x2 from the response variable y, and for that what I have to do is that I have to fit a model between I'll regress y on x2 first, and from there the residual will give me the part of variability in y which is not explained by x2, and then I expect x1 to I want to see how much of that residual x1 can explain. So, this is the idea, you know. I am interested in the marginal role of, I repeat, you know, I am interested in marginal role of x1 on the response variable y. So, first what I will do is that I will eliminate the part of variability that can be explained by x2. That means, I am just eliminating the effect of x2 from y. So, that remaining part I want x1 to explain, and I will see how much the remaining variability can be explained by x1. So, that is what the basic idea behind this marginal partial residual plot. So, to eliminate the effect of x2 from y, or to note the part of variability which can't be which is not been explained by x2, first I need to regress y on x2 and I will calculate the residual. That is, the residual part is the part of variability that is not explained by the regressor x2. Okay. So, first what I will do is that I will regress y on x2. That is same as saying that in general, in case of many regressors, regress y on all regressors except x1 if you are interested in finding the marginal role of x1. Since here we have only 2 regressors, I am regressing y, I mean y on x2 only. Suppose my fitted model is y I hat equal to theta naught hat plus theta 1 hat x I 2. Okay, so, this is the fitted model between the response variable and x2, and I want to introduce one notation here. I will put bracket 1, that means that response variable has been regressed on all the regressors except x1. Okay, this is the meaning of this. So, the regressor variable has been regressed on all the regressors except x1. Okay. And once we have this fitted model, we can compute the part of variability in y which has not been explained by the second residue by the second regressor. Okay. So, that is the residual. Residual EI is generally we write yi minus yi hat, but here I will write yi minus, this is the observed value and this is the fitted. Okay. When y is regressed on x2, this is the fitted value is yi hat 1, and I will put one bracket 1 here to denote that this is the residual, and also I will put y here. Okay. Little bit complicated notation, but this is the residual obtained from this regression. Okay. And also according to my partial residual plot technique, it says that in this plot the response variable and the regressor xj, suppose I am interested to find the marginal role of xj on the response variable. So, I will regress response variable and the regressor xj on the remaining regressors. So, here also I will regress x1 on x2. So, regress x1 on x2, and suppose my fitted model is x I 1 equal to alpha naught hat, simple linear regression model alpha 1 hat, and I am regressing on x2. So, x I 2, and this is my fitted model. And so, this basically see how much of the variability in x1 can be explained by the other regressor. Sometimes they are not completely independent, there might be little bit of dependence between them. So, we just want to eliminate the effect of or the contribution of the other regressors on the regressor we are interested on. So, here the residual is E I 1 x, I will put here, maybe little complicated notation. X I 1 is the original value of the first regressor, ith, I am talking about the ith observation, minus x I 1 hat. Okay. And then what this partial residual plot does is that I am talking about partial residual plot does is that it plots E I 1 y against E I 1 x. So, this plot is called the partial residual plot, whatever it might be. We will slowly establish the relation between these two, in case if we are assuming that the relation is linear, then what we can expect from the plot of this. Okay. Well, what pattern we expect in the partial residual plot. Before that, so this is an example, I hope you understood the technique at least of the partial residual plot. So, it says that you first regress both, suppose if I am interested to find the marginal role of xj on the regressor y, then I will regress both y and xj on the remaining regressors, and so there will be two regression model, and you find the residuals corresponding to those two regression models and plot them to get the partial residual plot. Okay. So, this is an example which consists of only two regressors. Next, I will just introduce the notations, the same concept only. I will just introduce the notations for in general case when there will be, for example, k minus 1 regressor instead of only 2 regressors. Well, so you know everything, and just some more notation here. In case of, say, for example, there are k minus 1 regressors instead of only 2 regressors. Okay. So, the partial residual of y for xj is defined as E I j y, the same notation here. I for the ith observation is equal to y I minus y I j. I hope you understand the notation. So, this is the fitted value when the response variable has regressed on all the regressors except xj. So, in my previous example, this is what this is nothing but the partial residual of y for x1. This is the partial residual of y for x1, okay, and this is the partial residual of y for xj. Okay. So, where yij hat is a prediction of yi from a regression model using all regressors except xj. Okay. So, I hope it is clear now, and this one this E I j y represents the variability in yi that is not explained by a model that excludes the regressor xj. So, this is the part of variability which is part of variability in y I which is not been explained by all the regressors except xj. Okay. So, what in other words also what does this mean is that this is sort of the effect of all the other regressors except xj has been removed from the response variable y. So, we want to see how much of this variability which is remained unexplained will be, how much of that variability, how much of this variability can be explained by xj. So, the dependence, I mean the dependence of the this complicated this residual E I j y is the part of variability in the response variable y which is not been explained by all the regressors except xj. That means that residual represent sort of the effect of all the other regressors except xj has been removed from the response variable y, and we want to see how much of this variability can be explained by xj alone. So, that is the marginal role of xj to explain the variability in the response variable y. Okay. So, this is what we want to mean by the marginal role of xj. So, this is the notation corresponds to y. Now, the partial residual of xj, similarly xj is regressed on the remaining regressors. So, the partial residual of x j is defined as E I for ith observation, j for jth regressor. We put the notation x here. So, this is x I j minus x I j hat. So, this is the fitted value obtained when the jth regressor is regressed on the remaining regressors, where x I j hat is a prediction of the regressor value x I j from a regression of x j on all other regressor variable. Okay. So, similarly, this E I j x represent the variation in x j that cannot be explained by other regressor. So, this is quite a routine thing. Okay. And now, we have understood the technique of partial residual plot, and we know little, we have some idea about the logic behind this partial residual plot, why it is so. And next, see, what we do is that we fit two regression model and we get two residuals, and now our aim is to find out the relation between these two residuals, whether these two residuals are linearly related or there is some other relation between these two residuals. Okay. Well, so little difficult. Okay, multiple linear regression model. We are in this setup, and we are interested to find the marginal role of x j on the remaining on response variable y in the presence of other regressors. Okay. So, in the multiple linear regression model in matrix form, in matrix notation, the model is y equal to x beta plus epsilon. Okay. You know what is this x, okay. You know what is this y is the vector of y1, y2, yn, and beta is the vector of. So, this x is a n cross k vector, sorry, n cross k matrix, and beta is k cross 1. So, beta consists of beta naught, beta 1 up to beta k minus 1, and epsilon is epsilon 1, epsilon 2 up to epsilon n. What is this x? X is equal to 1, x11, x2, x12, x 1 k, right, and then 1 x 2 1. So, this is for the second observation x 2 2 x 2 k and 1 x n 1 x n 2 x n k. So, these are the rows are corresponds to the observation. So, there are n observations and the columns are corresponds to. So, this is the column associated with the second regressor x 2. Okay. So, this one is x 1 for example, and you call it say x naught, and this is I should write maybe k minus 1, k minus 1, k minus 1, x k minus 1. Okay. Well, so what I want to do is that I want to break it into two parts. One is x j. X j is the X matrix except the jth column. So, I want to remove the jth regressor from this matrix. So, x j is the matrix obtained from X by removing the jth column here. So, similarly B j is also before it was beta naught, beta 1 up to beta k minus 1. Now, I am just removing the B j from this vector. So, this is called B j. Now, I will add those two things what I have removed from here I will add here, that is x j. So, x j is the jth column and B j what I have removed the coefficient from this coefficient vector, okay, plus epsilon. I hope you understand it. This is just adjustment, once you remove from here and then again you add it here. Well, and also we know about the hat matrix. If this is the model, then the hat matrix is H equal to x prime x inverse x prime, but if I consider only this part, if I just remove the jth regressor from the model, then that means x j here, x j here, j here, j here, then this is called h j. Okay. So, this is my h j. Now, what I will do is that I will multiply this. So, this is this is a Hadamard idempotent matrix. I will just multiply I minus h j, left multiply this matrix in this equation. So, what I will get is that I will get I minus h j, little difficult, but I hope if you concentrate you can understand. Yeah. So, this is I have multiplied this matrix the left hand side. So, again I minus h j x j beta j. So, see what I told, the beta j, beta is consist of originally beta naught, beta 1, beta j and up to beta k minus 1. And what I did is that this beta j is nothing but this beta bracket j is nothing but the same vector, just remove the jth one. So, it will become, before it was for example, it was k cross 1, now it will become k minus 1 cross 1, right. Anyway, so plus I minus h j, just this is the equation, x j beta j plus I minus h j epsilon. Okay. So, what you know is that we know that in matrix notation E equal to I minus h y, I minus h y. Okay. Then this one is the residual when y is regressed on all regressor except x j. So, then this one is nothing but E I j y, which is equal to, you can check that this quantity is equal to 0. This is 0 because if you multiply x j here, these two will cancel out, then x j minus x j basically, and then this one is nothing but according to our notation, this is nothing but beta j into, this is sort of when the residual obtained when x j is regressed on the remaining regressors. So, this is E I j x and I call it epsilon I star. So, this shows that, so this is the relation between if the jth regressor has a linear relationship with the response variable, then the two residuals will have also the linear relationship with the same slope, with the same regression coefficient. So, this shows partial residual plot should have a slope beta j. Okay, so what we understood is that we know how to compute two residuals, and we have understood that the relationship between these two residuals are also linear. There will be a straight line fit between these two residuals with the slope beta j. Now, I will just talk about different pattern of the partial residual plot. So, here you can see the partial residual of y is along the horizontal axis, sorry, vertical axis, and the partial residual of x j along with the x axis. And similarly, here you can check that the partial residuals are scattered around a line y equal to beta j x in both the cases, and if this is the pattern obtained for your example, then you can conclude that there is a strong linear relationship, and also it says that the less scattered indicates strong linear relationship between x j and y. Okay. So, this is one type. So, the less scattered indicates strong linear relationship between the x j and y. So, this is how the marginal role of x j in on y, and the other pattern is if the pattern is like this, in curvilinear band, then this indicates that the higher order term in x j or transformation such as 1 by x j or log x j may be helpful. That means, this indicates that the x j is not linearly related to y. either either you have to go for the higher order term for xj, or you have to go for some transformation on xj like log xj or 1 by xj. Okay, so this is how we find the marginal role of regressor variable on the response variable y, and I think I have to stop now. Thank you.